Okay, this is the extra credit video that goes along with the extra practice I gave you in class today. And I'm going to start by discussing sort of at a high level all the different things that you kind of need to know for the test. And the properties of logs I have here, I'll kind of go through it one by one. Basically, if you have two logs and you want to condense it down and they're being added, you multiply them in the one log. If you have subtraction, you combine it using division. And of course, as long as you have the same base in all of these cases. The power of a log says you can either use the power as a multiplication out front, or you can bring it up as an exponent. And these next three are sort of like extra little properties that are helpful to save you some time on the test. Log of 1 is 0, no matter what your base is. And then if you have a log with a base, and then of the same base as some power, it's going to simplify down to just the power. It's not that all this just cancels out. It's the fact that if you bring the p out front using this property up here, then what you always end up with is log base b of b is just 1. So whatever the power is would come out front and get multiplied by 1. So that's what's going on there. The next one looks really interesting. It is an exponential that has a log as the exponent. So I have a base, and then I have log base b of p as my exponent. So it simplifies all the way down to p. Now, those are the properties of logs, and we're going to talk about the different ways you can solve logs. So when you are solving logs, there's 4 sort of concept areas. So the first thing is, if you can get it down and condense it to a log equal to a log with the same base, you can simply say m is equal to n and solve. The hint for that is you have logs on both sides. The second area is if you can get it down to a log equal to a number, you're going to rewrite it by just looping around, b to the power of p is equal to m, and then from there you solve. And the hint from that one is logs on one side only. The third concept area is when you have no logs at all. So I meant to write this hint out over here. No logs, and you're solving an exponential equation. So what you want to do is isolate your power, and that's why I kind of boxed this one off. I would subtract 4 and then divide by -2. Then I would take the log of both sides, and that would allow me to bring the exponent down front as multiplication. And then from there you just solve. So we'll do some of those. And again, the hint there is there's no logs at all. The number one mistake students make in this area is they think they can multiply the -2 times the 3. No, this is a base that goes with this power, with the exponent. It makes it a little unit. You cannot multiply those two. The final one is a basic rewrite, which we've been doing for a while, and it's where it's given to you with a log equal to a number, and if you just rewrite it, you solve it from there. So those are the basic types of solving logs. There are some word problems, and I want to kind of go over that with you. And these formulas are going to be on the test, so you don't have to memorize it. So you have your basic growth or decay, where you have 1 plus r or 1 minus r. Remember, r is in decimal form always, so this would be a growth, and this would be a decay. And in these, you wouldn't ever hear the word compound, and you would never hear like half-life or doubling time, that kind of thing. If you do hear the word half-life, it's very similar to this one, but your base is 1/2, and then your exponent is elapsed time, like how much time has passed by, over your half-life time. I'll do half-life first. And the key here is if it has the word half-life in it, you know you want to use this formula. And that's time over half-life time. If you have a doubling and it says something doubles, you're going to now use a base of 2, and then it's time over doubling time, like that. And the final one is if you see the word compound, and you need to know n is whatever n is based on the number of periods per year, and that is this formula. A is equal to P, 1 plus R over n, and then n times T. And remember, R is in decimal form. Okay, so those are kind of the basic word problems that you'll have to use these formulas, and then of course you solve it using all the solving techniques. So let's set up some of these. I'm not going to do them all with you. I'll get you started on quite a few of them though. So number one, this whole section is just about condensing. So I need to get them down to 1 log. If I'm using addition, I would condense with log base 4 and I would say 8 times 32. And then, of course, I would simplify that down a little bit more. And this is the part you'd probably not have the calculator on. So you just have to do the multiplication there. So I get, this is going to actually be log base 4 of 256. And then I would know that when I raise 4 to the 4th power, I get 256. So this is going to simplify all the way down to a 4. So that's condensing and evaluating. Okay, I'm going to do another one that has a little bit more involvement. Let's do number 7 here. So the first thing I want to do is deal with my powers. When you're condensing down to 1 log, that's what you do first. So I'm going to bring this up here as a 1/2. So this kind of goes away. And then if I recognize that 25 to the 1/2 is just the number 5. So this is all going to be the number 5. So I'm going to actually say log, and then I'm going to have 20 times 5 because of this addition, and then that will be divided by the 10 there. So this is going to simplify down to log, and then 20 over 10 is just 2, and it's going to be a 10 here. Now, you don't want to leave it just like that because you have an understood base of 10. This is a common log, so you know the answer is going to be a 1 because 10 to the first is 10. So that's how you do the top section. So let's do some of the solving. And again, think about which area you're in that we talked about on the back. Okay, so and you know your hint. So when I look at this very first one, I recognize there's no logs at all. So I'm going to actually isolate the power and then take the log of both sides. So I do that by adding 8 to both sides. So I'll end up with 2 to the 5x minus 3 is equal to, and then I get a 4. Now this is one you actually have a choice because you have a base that you could rewrite. I'm just going to show it to you this way because it's a little bit quicker and it's less mistake prone. So I'm going to rewrite the 4 as 2 squared. So I'm going to have 2 to the 5x minus 3, and then I have 2 squared on the right side. Then I can just focus in on solving my exponents as an equation. So 5x minus 3 is equal to 2. Add the 3, so I get an x of 1. So that is how you could do one of those. Okay, so that was one of the methods or one of the types where you had to basically take the log of both sides or change to a common base. So that worked as changing to a common base. So let's do another one sort of in that same area. Let's do number 13. So there are no logs at all, so I want to isolate the power, and this is the power. So I'm going to add 4 to both sides. So I'm going to get a negative 12 here, and then I would divide by this negative 2 next. So that's gone, and then that's gone. So I end up with 7 to the x minus 2 is equal to a positive 6. Now, how do we finish from here? We're going to take the log of both sides. So log of 7 to the x minus 2 is equal to log of 6. And then that allows me to bring the x minus 2 out front as multiplication. Use parentheses here. And then I'm going to divide both sides by log of 7, like this, and then I would add 2. So I'm going to end up with this in the calculator and then just add 2 to get to the final answer. Okay, so I'm going to show you how to do this one in the calculator just to make sure you get the right answer. So here is the calculator, and I need to do log of 6 divided by log of 7. So I'm going to make sure to close the parentheses. I don't know if y'all can see that. I'll kind of zoom in. So log of 6, close the parentheses, divided by log of 7. I'm afraid y'all cannot see that. Log of 7. And then that gives me a value. And then from that value, I can just go ahead and continue on. And remember, I had to add the 2. So just add 2, and I'm going to get 2.921. So x is equal to 2.921 for that one. So be sure to check your answers against the keys and make sure you're doing everything right in the calculator. Now, so let's go on to a different type. When I look at number 14, it looks like I have logs on the left and just a number on the right. So when that's the case, I know I need to condense this left side and then rewrite it. So I'll condense the left side by doing division, because this is a subtraction. So log base 2, and then I have 3x minus 2 divided by 3, and that equals 3. So all I did was divide this by 3, okay? Then I rewrite it by basically looping around, so 2 cubed is equal to all this. So 2 cubed is equal to 3x minus 2 over 3. And remember, 2 cubed is just the number 8. So then I would multiply both sides by 3, clearing this denominator. And then, so on the left side, I have 8 times 3, which is 24, is equal to 3x minus 2. So add 2, get 26, and then divide by 3. So it's just going to be 26 divided by 3. All right, so that's another type of problem. And that would be, if you wrote down the notes on the back, that would be the second one right here, where you basically get it down to 1 log on the left side. Let's do one more like that, and that would be like number 25. So 25, I want to bring the power up first, and so the 2 here is gone, and I'm going to again say log, and then I have x squared divided by 4, and all that is equal to 2. Remember, if there's no base written, it's an understood 10, and when I loop around, I get 10 squared is equal to x squared over 4. And then I would multiply both sides by 4. So here I get 100 times 4, and that's going to be 400, of course. And when I take the square root of both sides, remember plus and minus, I get x is a plus and minus 20. Now, I have to go back to the original equation, not this one that I have here, but when x was by itself and 2 is out front. And the negative 20 is not going to work because you cannot take the log of a negative number. So that would be the answer for that one. So I've done a couple from 2 different families. Let's do some from this one where we have a log equal to a log. That would be ones like number 21. And that one is already set up nicely for you. So it's 1 log equal 1 log. So I just say 5 minus 3x is equal to 4x minus 9. And you literally saw from right there. So I'd add 3x to both sides, getting 7x there, and I would add 9 to both sides. So then I get 14, and then x is going to be a 2. Now always remember to go back and test it. So 5 minus 3 times 2. Well, guess what? That's a negative 6. So 5 minus 6 is a negative 1. There is no solution to this problem. So that's going to really help you understand this concept. You won't always get a solution. Now, let's do another one sort of like that. Number 20 is one sort of like that. Now, again, it's already condensed down. So I'm just going to basically say 3 minus 4x is equal to x over 3. And you can only do that when a log equals a log. So I would probably multiply both sides by 3. Think just, you're going to distribute over here. So you get 9 minus 12x is equal to x. So I'd probably add 12x to the other side to get 9 is 13x. X is going to be 9 over 13. Now, there's one other final type when I said it's just a basic rewrite. That's what I called it, a basic rewrite. That would be ones like number 19. So when you loop around, n cubed is 125, and then this is where you'd either use the table or the calculator, and n is going to be a 5 there. Number 12, very similar, but this time you kind of loop the other way. So you have 3 to the negative 5 is equal to n. So basically, you'd use your table for this, and when you raise 3 to the 5th power, you get 243. But it's a negative 5, so it's going to be 1 over 243. That is your answer for that one. Now, I do want to talk through some of the, or set up some of the word problems down here. So I have the first one. A chemical has a half-life of 8 years. How much of 9.2 grams will be left after 18 years? So this is just saying how much do you have after 18 years. So you're looking for your Y. You're starting with 9.2. It's a half-life. And the half-life is 8 years. So it's going to be time of 18 divided by the half-life. And you literally just plug that in the calculator and get that answer. So that's how you do that one. 27, the annual growth rate of a moose population. And the word annual right here does not mean this is a compound problem. You must see the word compound for it to be a compound problem. So the growth rate is 5.3. A few years ago, the population was 325, and today it's 500. Find the number of years that have elapsed between the initial population and today's population. So the initial population was 325, and it grew to be 500. You know the growth rate, 0.053 in decimal form, and then I am just solving for x. Okay? Now, this is one where you want to isolate the power. So I'm using one of the methods we already talked about. I'm using this method right here, where you isolate the power. So I'm just going to divide both sides by 325. So divide 500 by 325. So I end up with 500 divided by 325 is equal to 1.053 to the x. Now I take the log of both sides, so the log of all of this is equal to the log of this, and the x will come down front. So I end up with x equal to log, and then it's 500 divided by 325, all that in parentheses divided by the log of 1.053. Okay, and then you can just do all that in the calculator. All right, number 28, let's set up that one. Anna deposits $1,500 into an account with an interest rate of 2.5% compounded monthly. This is when I know I need the compound interest formula, and there's 12 months in a year. How long will it take for Anna's money to triple? Now, we talked about this in class. I could just do 1 and then 3, but because they gave me a specific amount, I'll just do 1,500, and when that triples, that will be 4,500. And then I have 1 plus my rate of 0.025 divided by n of 12, and then I have n times t. And then again, you're going to isolate the power and take the log of both sides to solve that. All right, so what I think I'm going to do is I'm going to obviously send out this video, and then I think I will maybe have the key available if you want to check it first thing in the morning when you get there. And then you'll get extra credit for the video and the extra worksheet. Hope you have a great day, and I will see you tomorrow.